Hello, today in chemistry we reviewed unit conversions. So some basic reviews are as follows. When you use unit conversions, you generally put the unit that you want to lose in the bottom of the factor so that it will cancel, and the unit that you want to go to in the top. Mathematically, you will multiply by the top number and divide by the bottom number. Now, for this to work out, you have to have a valid unit conversion. For example, there are 24 hours in one day. There are 12 inches in 1 foot. So if you, for example, said that you want to know how many seconds are in an 8-hour workday. All right, you must begin with the number and unit that you are given. In this case, we know that we have 8 hours. We are trying to change that into seconds. All right, so the first unit that we want to get rid of is hours. I may not know off of the top of my head how to go straight to seconds, but I do know that every 1 hour is 60 minutes. I don't want an answer in minutes though, so I need to add on another factor where I get rid of minutes and I go to seconds. Every 1 minute is 60 seconds. In class, we had pointed out that this could also be achieved in one step because some people are aware of the conversion factor that 1 hour is 3,600 seconds. All right, regardless of which method you use, you are going to start with the 8. In the top method, we would take 8 times 60 times 60. In the bottom method, we would take 8 times 3,600. And regardless, they should both give you the answer that there are 28,800 seconds in an 8-hour workday. All right, today for the sample problems that we are doing, I want to focus in on units of energy. All right, in section 1 or 2 of this chapter, we had discussed that there are joules, which are used to measure energy, a capital J, and there are calories, which is a lowercase cal. Typically, joules are used for fuels, like gasoline, diesel, batteries, whereas calories are used for foods. All right, and we were already given the conversion that 1 calorie is the same thing as 4.184 joules. However, we need to recognize that on the assignment that you are going to complete tonight, sorry, I meant that to be a different color, there is a lowercase c and there's an uppercase c. So there are 1,000 lowercase c calories in 1 capital C calorie. Now that might not seem like a very big difference, but the capital C calorie is a food calorie, which can also be called a kilocalorie. All right, and what we discussed in class is that typically a recommended daily diet for the average grown human is 2,000 calories of food. So 2,000 calories of food, that's a capital C calories. That would be the same thing as 2 million scientific calories, which is a lowercase c. So these are scientific calories. Why do you think we use kilocalories or food calories? Because 2 million would be a lot to keep track of. So a new conversion factor that you are going to want to commit to your memory or to know for your homework is that there are 4,184 joules in every 1 capital C calorie. Or you could write that as 4,184 joules is equal to 1 kilocalorie, kcal. All right, and remember that the prefix kilo means 1,000 times greater than the base unit. So you could say that 1 kilometer is equal to 1,000 meters. All right, all of this information will be very helpful for you tonight as you do your homework. This in particular, you need to know that small c calories, there's 1,000 of those in 1 food calorie. There's 4.184 joules in 1 scientific calorie, or 4,184 joules in 1 kilocalorie. Please pay attention on the worksheet to whether they are using a capital C or a lowercase c, because